So, yeah, am I clearly audible?
Yes, sir.
So today's topic, lab 5, is regression analysis. Regression analysis. If you have any problem understanding, let me know. Or if you cannot hear me properly. So regression analysis, let's try to understand the concept. Let's start with a simple concept. So if I plot a graph like this way, I have x-axis, I have y-axis. So let's say you have a very simple equation like v is equals to IR. So you have done this thing previously. So on your x-axis, there goes your v. On the y-axis, there goes your I. Okay. So if you have some values of voltage and current, you can put those values in the graph. Okay. So let's see. Let's say the R value is, assume R value is 3. So for V1, or V is equals to 1, I is equals to 1 by, so let's start with 3. 1 by 3. Okay, for V is equals to 2, I will be equals to 2 by 3, like this. You can easily plot the graph like this way. So you have the values. Can you please turn off the video? 226. So if I put these values in the graph, so it may look like this. For instance, this is my value 1, 2, 3, 4, 5, 6, like this way. And let's say we have the values, we just plot it in the graph like this. Let's say it goes like this way. Now we have 6 values, let's say 6 data points. I have a graph like this. Okay. Now what we can do, we can draw a line. We can just draw a line through all of these things. So let's just draw this line, a clearly a straight line. The points, each of these points should be on top of this line. Should be on top of this line. Okay, because we know exactly based on the equation, we know exactly the points. So this is like a simple plotting, and from x and y value we have the equation. You can just simple plot the data in the graph. Now let's say in this graph, if I ask you these questions, what is the value of current if V is equals to 3.5? If my voltage equals to 3.5, what is the value of I? Can I find it from the graph? Can I find it? You should respond, some people. Some of you should respond, otherwise it becomes difficult for me to take the class. Yeah. So 3 was not originally one of the data points that we have, but since we have the straight line, we can easily get the values, other values as well. So for 3.5, I can get this value. Okay, this is the point. So this is the value of I. Or if I want to find something like, for instance, 0.5, I can also get the value from this data point. So some of the value that does not exist in the original data, original graph, but we can still get some value. This process is called interpolation. Interpolation. Something within the graph, I can get the value. But what if the value is outside? Let's say I want to get the point for value 8, voltage equals to 8. But that point is not in your graph directly. So what I can do, I can extend our graph like this. And based on that, I can get the value for R, 8. This is called extrapolation. Outside the graph, that is extrapolation. Is it okay? So This way I can, if I have some equation, I can plot the graph, and from that graph I can extend the line, or inside the line I can get the values of other values, data points for other values. I can figure those things out. Achha. A very simple thing. So this process is something that we call, what we have seen here is called curve fitting. Curve fitting. So I have the data points, I connect those data points one to another, okay, and feed my data and plot a graph like this. So this is the curve that we have, okay. And from this curve, we can get some value like interpolation or extrapolation. We can extract some other values as well, unknown values that we previously did not know. Now, you have done something like this in your experiment in your first year. The difference was that when you were doing the experiment, you didn't get the exact value. So some of the values were like the color, or let's say for point of 2, you get the value here. For 3, you get the value a little bit larger. It was experiment. So you are doing lab experiments. Some of the values are not. For 4, almost like this. For 5, this is like this. But when you had this data point, when you had this kind of data point, what did you do? Let me redraw it like this way. Let's say the data points were like this. So what did you do? Did you make the graph like this way? In this?
No, so you draw a straight line passing through most of the points.
You draw a straight line, right? So
yeah,
this is passing through the points. So we didn't want to do it like this way. This is like exactly curve fitting. Whatever the data points that you have, like this is my first point, second point, third point, fourth point, 5 and 6 point. If I connect them directly, one after another, this is called direct fitting. Okay, you're just directly connecting all the data points. So if you write this function in your MATLAB, plot x comma y for some values, you will get a curve like this way. Directly connect one point to the next. Okay. But this does not represent the actual scenario. Like we know that there can be some mismatch in the reading when you're doing the lab experiment. So we do not fit the curve like this way. Rather, we try to draw a straight line. A straight line that is sometimes that matches the whole point. There can be some small mismatch. Something may not be on top of the line, but something very closer to the line. We try to draw a line like this way. Okay. So when you try to draw a line, again, we can perform interpolation, we can perform extrapolation like this way. So this concept, like drawing a line from most of the matching points, this is something that we are interested in. Okay. So the thing is, so when it comes to curve fitting, there are 2 scenarios can happen. One is you know the exact values, like from an equation. If you're using equation like V is equals to IR, or let's say F is equals to G M1 M2 divided by D square, you know the exact value. So if you are putting the values directly from a graph, so you know the exact value, so you can directly connect. You can directly connect all the points together, and that will be your curve fitting. If you do not know the exact value, like your lab experiment, in such cases, we want to draw a line that is the best match line. Okay. We want to find the best match line. Okay. So this one is called regression. We need to find the line that is best match. That is called the regression concept. Okay. We'll discuss more further. Is it okay so far what I have given you the introduction? Any question? কারো কোনো question? Okay. So now the thing is, it does not have to be a straight line. The line can be like this way. So in such scenario, should I connect it like this? Or this one looks like a much better match? Red one or the blue one? Which one? Yeah. red one. So the red one do something that is called, that is something that is the trend of the data. That's what we are actually interested in. Trend of the data. It is not matching the exact point, but trying to find the trend of the data, where the data actually leading. Okay, that will give you much better result in concept like this. So that is what we're interested in regression. We want to understand the trend of the data. Let me give you another example. You say you are trying to do something like house rent. Okay, house rent. On the x-axis, you have the number of rooms. Okay, and in the y-axis, you have the rent of the house. Okay, so number of rooms 1, number of rooms 2, number of rooms 3, room 4, 5, 6, and you are collecting the data. Okay, you are let's say you want to find a house in Uttara, and you are trying to collect the data. What should be the likely price? So you take the data and put it there. Let's say this is 15K, this is 18K, this is 21K, this is 24K, like this way. And I'm trying to put the values in the graph now. Let's say for one data point that you have, you get the value for one room. The price of the house was 15K. Then you go to another house that is 2 rooms, and you find the house of the price is, let's say, 17K. But you find another house, same 2 room, but this price is 18K. And you find a 3-room house, its price is, let's say, 20K. But again, another data point, 3-room house, its price is 24K. 4-room house, its price is, let's say, 3K. 5-room house. Okay, so you have the data distribution, very simple, like 6 or 7 points, distribution like this. Now, as you can see, this is the realistic scenario. You cannot directly connect those points to estimate the values, like what is the likely value of 3 or likely value of 2. So if I do something like this, then the curve will look like this. So this does not make any sense. So what we can do, we try to find like the best match. Okay, we can try to find the best match going. What is the likely price of a let's say 3-room house like this? So when you do something like this, you try to take as much data as you possible so that you can actually can make a very good estimate. So you take lots of data, lots of data points, and see they are distributed. And from this one, you try to plot a graph like this one. Okay, draw a line like this. Okay. Now that line is not going to give you the exact price. Let's say for one of the house, let's say 3-bedroom house, your graph is showing you that the price of the house should be 21K. Sorry, wait, I have to take this call. Okay, sorry for the delay. Had an urgent call. Asha. So we are talking about the house rent. So the scenario is like, let's say that line we draw, we can understand the trend, but not the exact value. Let's say you have a house, like 3 room house, you found a house, and the curve is showing you the price of the house should be around 22K. But when you go there, you see they are asking the price, let's say 28K, and it does not match. So scenarios like this can happen because you can see we are only considering the number of rooms as a factor, but there can be other factors. Like location is a very important factor. So if you are like, for instance, you are in Uttara 10, the price can be a little bit lower. If you go to Uttara 13, the price will be higher. Then number of, let's say, bathroom. Okay, number of bathrooms, number of balconies. Okay, then which floor? If it is third floor, that can actually increase the price. So there are many factors associated. You cannot just directly predict from one data. But for the sake of this understanding, we'll just assume that based on the rooms, we are trying to predict what is the likely price of the rent. Now, here comes the question. The question is, let's say, is the concept clear? Any question based on this? The concept of curve fitting. Any question from anyone? Okay. Okay. So let's say you have the data like this way. You have the data like this. Okay. Now the question is, let's say I can draw a graph. I can draw a line like this. But I can also draw a line like this, right? Now, how do you say which one is the better one? The red one or the blue one? Which one should be the best approximation of the data? Okay. Which one is the best approximation of the trend of the data? You get the question? Which আছে নাকি চলে গেছে?
So without the points, can we really say which one is the best
Yeah.
approximation? I mean, without the points, how can we predict which line or say which line is the best approximation?
Yeah, these are the data points that you know for sure.
Okay.
These are the data points we know for sure exact value, and we are trying to draw a line between them. And but the thing is that we can draw many lines. This is another line. This is another line also. I can draw the line like this. This is clearly not the cyan one. This is clearly not the best fit line, the last one. So we can actually draw hundreds of different lines. So the question is, which one is actually the best one among them?
I think the red one.
Yeah.
The red one.
Yeah. How do you explain? How do you actually do that? How do you actually say that?
Yes, for the red one, you have almost same number of points alternating between it.
Yeah, I understand. So we have to. So this is based on your visual understanding or visual expression, but we need something like, for instance, mathematical representation. Okay, we have to do something mathematically. Which one is the best fitted line? Okay, and that's why the numerical analysis comes. We cannot just say from eye view. We have to do something mathematical representation. Okay, we have to find some mathematical representation of the best approximation. Is it okay? Any question? Let's see. Now, in terms of that, so we are trying to find the best mathematical representation of the line. So the equation of the line is like y is equals to mx plus c, where m is the slope and c is the intersect. So if I try to put it here, let's say this is the red line. This is my c value, and this theta, the tangent of the theta, that is my slope. Okay. Now for this, for the blue one, let me draw it here again. If I try to draw a line, let's say this is my one line, this is my another line. So for the red one, this is my c, and this is the tan theta, that is my slope. Let's say that is my m. And for the green one, blue one, this is my C, and this angle, that is my tan theta, and this is my M. So as you can see, when you draw different lines, each line will have a different MC pair, right? Every line will have a distinct MC pair. The M value can be same, but the C value has to be different. Only then the two lines are different. Okay, so that is the equation of the line. So if we draw a line, we can see every one of them will have a distinct pair like this way. So based on that, we can actually represent a line. Let's say this is my line 1 is y m1x plus c1. My line 2 is equals to y m2x c2, like this. All the lines can have. So every lines will have a different values on m1 c, and we have to find the line that actually the best fit. Okay, so that is a representation of the line. Now representation of line. Now the representation of error. So this was our representation of line. And let's see how we can represent the error. Now let's write the equation to something like this. Y is equals to theta 0 plus theta 1 into x. Okay, just writing m and c in terms of theta, just for representation, easy representation. Achha, this is the equation of a line, any line. Achha. So let's say this is my curve. This is the data points that we have. And this is the line that we actually draw. Okay, so this will be my theta 0, and the slope that we can find, that is my theta 1. So here we can find the slope. Tan theta 1. Now, how do you find the error? We try to find the error based on like this way. See, for each of the data points that we have, let's say this is my first data point, this is the second data point, third data point, fourth data point, 5. We can represent this like this way. This is my point x1, y1. This is x2, y2. This is x3, y3, like this way. So all the data points that we have here, we can represent like this: x1, y1, x2, y2. Like this way, we can say up to I have xn, a, yn data points. And this is my predicted line. The red one is my predicted line. So that is the value we are predicting. So the predicted value for this one is actually this, right? So the for exact point, same x, y different. And the prediction value of y is a little bit different. So the predicted value for this one is this one. So this is your x1, y1 prime. Let's say prime is the prediction one. So for x1, y1, we get x1, y1 prime. That's the prediction that we get. For x2, y2, we get x2, y2 prime. For x2 value, this is the prediction that we got. For x3 value, this is the prediction that we got. So for x3, we have y3 prime. So similarly for xn, we have yn prime. This is the predicted value. For the line we draw, these are the values that you actually get. So what will be error? What will be the error? The error will be the distance between these 2 points. This one. If I draw a line, a straight line, that is the error. Error in our presentation. Okay. So that is the error that is. So the actual value is this. Actual value is this, but I'm actually predicting this. So the difference is the error in the prediction. So that we can numerically represent it like this way: y1 minus y1 prime. That is the error from the first one. Similarly, y2 minus y2 prime. That is the error from the second one. Then y3 minus y3 prime. So this is y3. This is your y3 prime. This one. So y3 minus y3 prime. It can be positive as well as negative. That is your error. So similarly, yn minus yn prime. That is your error. Okay, and the error can be positive as well as negative error. Is it okay so far? বোঝা যাচ্ছে আমার কথা? Yeah. হাসিনা ঘুমাইছে?
It's okay.
You barely see anyone else talking. Okay, so this is the representation of line we are trying to understand. The question was, we have this scenario and we can show many lines. We want to find the best fitted line. That was our question. So to do that, we are trying to find first, this is the representation of the line. Then representation of the error. This is the representation of the error. We can actually find the errors for this line. Similarly, for another line, we can also find the errors for that one as well. Then what do we do? We have the errors. We calculate something, that is, we sum all of these errors, y1 plus y1. But as you can see, this can be positive or negative. What we do? We try the square of it. Okay, so we square all the errors. Error value that we get, we take the square of it. So square of this one, square of this one, square of this one, and sum them all up all together. Okay, so this becomes like this way. If I write it, my errors are like y1 minus y1 prime square plus y2 minus y2 prime square dot 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 all of them up to yn minus yn prime square. So this is called sum of square error. I am summing the squared error. So that is your SSE. And if I want to represent it more easier way, I can use this summation sign. For I is equals to 1:n for first data point to nth data point. Now my value is like yi minus yi prime whole square. That is the equation of your summation of SSE, sum of square error. Okay, and we represent in something using, let's say, j. Okay, so that is your error function, or we call it the cost function. We call it the cost function. So if we try to do it like this way, so with j, my cost function. So cost function means the cost of perition. So we draw this line, and for doing this line, the total error that we actually got. Okay, and this is represented by this one, summation of I is equals to 1:n এর জন্য yi minus yi prime, sorry, yi prime whole square. We can write it a little bit like this way, summation of I is equals to 1:n yi minus yi prime is the perition. So based on the equation that we have, that is your theta 0 plus theta 1 xi. Okay, and then whole square, then your square, because this one is equivalent to this one, because yi prime, that's the perition. This is your yi prime, y prime, that perition attribute, and that is equal to theta 0 plus theta 1 x. So we can write this equation like this way. So this becomes my cost function, theta 0 minus theta. Now, as you can see, yi is the actual value that we have in this equation. Yi is the actual data point that you already have. Xi is the actual data point that you already have. And this theta 0 and theta 1 is the variables. These two are the variables of the equation. That's why I write it like this way. So the equation depends on this theta 0 and theta 1. For different theta 0 and theta 1, we'll get different lines, and for different lines, we'll get different errors. কথা বোঝা যাচ্ছে? Are you getting me? Different theta 0, theta 1, it will give me different line. And for different line, that will be different total loss or total cost. Is it okay? Is it okay? যারা ঘুমাচ্ছ একটু পর কিন্তু একটা কাজ দিয়ে দিব ম্যাটল্যাবে, তখন কিন্তু আর করতে পারবে না কিছু। আচ্ছা, so for different theta 0, theta 1, we can get different line, and different line will have different cost, and we can calculate from this value. So we are trying to find that one that has the minimum cost, right? That's what was our goal. We can draw many different lines from here. We can move many different lines. For each one of them, we can find the, for each and every one of them, we can find the cost associated with it. And we want to find the line that has the minimum cost. That line is the best approximation of the trend. Is it okay, the concept? Is the concept clear?
So could you repeat the last statement, sir?
Yeah.
The last statement you just made.
Last.
About making the best approximation with respect to this values of
Yeah.
theta 0, theta 1.
Yeah. That's the question. হ্যাঁ বলো।
স্যার ইরোরের ভ্যালু যত কম হবে কস্ট তত কম হবে না স্যার?
Yeah, it is the giving you the error. So the less error that you have the less cost. We are trying to find the line that has the minimum error or minimum cost, right?
Yes, sir.
Any question? So let me rephrase those things. So what we are trying to do, let's start from again. We are trying to understand we have different lines. When we have data points like this, we can draw many different lines from there, and we want to find the line that actually our best approximation. To do that, for each of the line, we can find the associated cost for each of the line. Okay, so we can find it based on the sum of square error. We can take this error from each one for this line, and trying to find what is the error associated with each line. The line that gives us the minimum error will be our best fitted line or best approximation of the trend. Okay. So এখানে গেল. So we have come up to this one, minimum cost. So now this becomes like a optimization problem. Because as you can see, we can have 1,000 different line that goes through those points. So if we should I try each and every one after another, or is there any better way to do that? That becomes the optimization problem. We want to optimize the process so that we can easily go to the solution. Okay, so we are trying to optimize this function. This is our cost function. This equation we are trying to optimize. Okay, so based on theta 0 and theta 1, we'll change the value of theta 0 and theta 1, and we are trying to find Can you hear me? Yes. Okay, so sorry, the electricity was share the screen. Okay, so this is now an optimization problem. I have this equation, say of theta 0, we have two dependency, theta 0, theta 1, that is equals to summation of I is equals to 1 is to n এর জন্য yi minus theta 0 plus theta 1 x. What is it? Now we have to find some value of theta 0 theta 1 so that we can get the maximum value. Achha, to represent this graphically like this, let's say for theta 0, let's say this is my j, and same simultaneously for theta 1, there should be a j. Let's say for, if I try to get a curve like this, let's say we get a value of theta 0, let's start with this one. We take the value of theta 0 for this one, we get the cost associated with this one. Just for theta 0, let's assume for now. Then what do? You see the error is very high. Then you change it. Take another value of theta 0, and you find that the error is now increased up to this one. So this is from iteration 1, then this is from iteration 2. Okay. Now you get the error like this. The error has increased. So that means you should go in opposite way. Let's take the value of 3 like this. For theta 0, this third iteration, third value, you get a value like this way. You go now here. Okay, this is decreasing. So you take another value, it goes like this. Let's say 4, then another value like 5, 6, 7. So this is the minimum point that you have. Okay, this one, the smallest one, this is the smallest j, and that value theta 0, that's your best value of theta 0, for which you can get the minimum cost. For this one, this is the minimum value. For this value of theta 1, for this value of theta 1, the j you get is the minimum one. Okay, so that theta now, as you can see, when you have to try to find the minimum of a graph, so you have to take the derivative of it. The derivative actually gives you the, when the derivative becomes 0, that gives you the minimum error, that gives you the 0 value. Okay. So this was our equation, and we are trying to find the minimum of it. Okay. Find the value. We are trying to find the value of theta 0 and theta 1 for which the j is the minimum one. So what we have to do, we have to take the derivative del j with respect to theta 0. Similarly, with respect to del j with respect to theta 1. This is partial derivative. You have theta 0, theta 1, two equation. So if you try to take the derivative, you have summation s square. So 2 comes in the front. Then summation I is equals to 1 is to n yi minus the whole thing, theta 0 minus theta 1 plus theta 1 into xi. Okay. This one into then the derivative of this one inside. So we have 0 minus 1. This gives you a derivative. Similarly, for this one, you can also calculate like this way, 2 into same. I think for this one, theta 1x, so this will be your minus x sine. Okay, you can find the derivative of the equation. So your condition will become like this: when this derivative becomes 0, the value of theta 0 for which this derivative becomes 0, that's your minimum value. Similarly, del 0 of del theta 1, the value of which from this equation you can actually find the value of which for which that it becomes 0, that will give you the minimum value of theta 1. Okay, just simple optimization problem. Achha, this kind of optimization, you can do it in many different ways. So one process is iterative way. Okay. Another is algebraic method. Now the iterative methods are called stochastic gradient descent. Stochastic gradient descent algorithm. So it actually tries to reduce the gradient. As you can see, this is your gradient. It tries to reduce the gradient gradually to find the minimum one. Okay, so that is the stochastic gradient descent. It works iteratively. Achha. The algebraic method that is the numerical one using matrix multiplication, that comes directly from this equation. Now, when you have lot of data, like very high value of n, when you have very high value, n means the data points. When you have a large amount of data points, these values, stochastic gradient descent is the best one. There are other optimizer like Adam optimizer, then BGFS optimizer. There are different optimization algorithms. This works well, and these are actually used practically when you have lots of data. But when your n is very small, your matrix manipulation will work, and that is what is actually discussed in your book. So we'll follow this one for now. And you will learn this one later in your AI course, machine learning. You will always learn in the machine learning process. We always use a stochastic gradient descent. This is called SGD, stochastic gradient descent. So those are more like data intensive calculation. When you have lots of different data, then we actually go for those kind of iterative process. When you have a small amount of data, your matrix manipulation is enough. Now, so how to perform this matrix manipulation? That is very simple. You have to take the inverse way. And the equation for this matrix manipulation, you will find it in your lab manual. Okay. As well as the derivation is also given there. Very simple derivation. Let's see. Open it now. Open actually now. Can I see the screen? Can I see the laptop screen?
Yes, sir.
Okay, so this is your linear and nonlinear regression. And we have already discussed these things. We have discussed the least square regression problem. We are trying to find the minimum value, minimum square error. Right? That's why it is called least square regression. And then see, these are the equation, blah, blah, blah. And you can see from this one, this is the derivation. You can see A0 and A1. The A0 and A1, that's your equal to theta 0 and theta 1. They are just represented like this way. So if I try to write it here, the numerical equation. So you try to find the A1 first. That will be equals to n into summation of xi yi minus summation of x summation of yi. Then n into summation of xi square minus summation of xi whole square. And your A0 is equals to y bar, that is the y mean, into A1 into x bar. You don't have to memorize it. You can actually just derive it by yourself. So here, this is the equation. This is the numerical approach. Okay, this is the numerical approach. For the iterative approach, you have to write a for loop and gradually try to find the minimum value of theta 0 and theta 1, for which you can get the minimum value of j. So you don't have to worry about the iterative process for now. You just can wait for the numerical approach. And it is done here, but they actually did it here. This is the old lab manual. It was done using for loop, but we don't actually need to use any for loop here. Let me directly share screen, share. No. So can you see the tab screen? Okay. Acha. So these are the two equations that you have, A0, A1. A0, that means this is a theta 0. We just write theta 1. So this calculation you can actually do directly using MATLAB. You don't need any for loop. So let's say, for instance, this one, the numerator is equals to n. N is the length of your number of data points that you have. Okay. So you can have here n multiplied by summation of xi yi. So your xi, x is a vector like this way. Let's say 1, 2, 3, 4, 5, 6. And for each of the value, you have corresponding values of y. Let's say 10, 12, 15, 6, 16, 20, like this way, each values. So what do you have to do? Let's say summation of multiplication. This is like your dot product. You want to multiply this point with this point, this one with this one, this one with this one, like this way. So point-wise multiplication. I believe you already know these things. So point-wise multiplication, we use this dot multiplication sign. Okay. For x multiple y in your MATLAB, I'm writing the code. This will not work because why it will not work?
Not element or quantity.
Yeah, element mismatch, dimension mismatch. Actually, the first one x is 1/7, y matrix is y 1/7. For matrix multiplication, it has to be 7/1. Okay. Otherwise, this is going to give you a dimension mismatch. This one is going to give you a dimension mismatch. So, but we don't need this matrix multiplication. We need element-wise multiplication. We're trying to multiply point by point, then sum. So if I write the code, it becomes like this way. N into, I'm writing this part. Summation of x dot multiplication of y minus. Then summation of xi. That means the summation of values of x in the array multiple by summation of the values of y. That is the numerator part. Also similarly, very easy. The code is very easy today. Denominator is again n multiple by summation of xi square. So x dot square. You see x is a vector now, and you want to multiply, you want to take the square of each and every one of them. So that's why you have dot square, and you have the summation of it. Summation of it dot square minus x summation of x, then square. Okay. Then you can just write your a0 should be equals to, so a1 should be equals to numerator divided by denominator, like this, and then a1. If you plot this equation, if you have the example given, and right directly, if you write it like this way, you can get the answer from here. Is it okay? Any question? কারো কোনো কোশ্চেন? কারো বুঝতে কোনো সমস্যা হচ্ছে? Okay, I will upload the video for your for some.
স্যার লাস্ট লাইনে ওটা কি লিখছেন ডিনোমিনেটরের লাইনের পরেরটা
এটা আচ্ছা, এটা হচ্ছে এই জিনিসটা, সরি, I am trying to find this one, right? A1. So A1 should be numerator divided by denominator, right? This is the numerator portion, and this is the denominator portion. Numerator divided by denominator. This will give you the A1. Yes, and A0 is equals to mean of y minus A1 into mean of x. Okay. So this is your code, very simple. There is nothing complicated about it. So that's your very simple way to actually perform this kind of regression analysis. This A0 and A1 or theta0 and theta1 is going to give you the best value. Let's say you have some data points here like this. The best value for this line, the best fitted line. The A0 will be like this, and this one will be A1. So if you draw this line, you will get the best match from that one. Okay. So that's the very simple way to find this curve. This is the regression curve that you have. Least square regression based on like this way. So now please go to your MATLAB. If you look at your lab manual, there is a value given. Okay. X and Y data points are given to you. If a table is given in the demonstration. Okay. So take the X value in an array, take the Y value in an array, and using this way, the one I just showed, using this way, and directly try to find the value of A0 and A1. Okay. And it should match with the verification. It should match with the value that is given there. You have only 3 to 4 minutes. Please do it quickly and share the screenshot in your comment section, in the chat section. Share the screenshot of your code and the output. Okay. You can use X file, try to use an MLX file or X file, whatever you prefer. No problem. Do it quickly. Okay. I will give you 3 to 4 minutes, then I will start checking. I will only check the top 5 to 10. Okay, quickly.
কোন টেবিলটা ইউজ
So what is it?
লেফট
So-
সাইডে লাস্টেরটা নাকি লেফট সাইডে প্রথমটা
So please what should we calculate this?
Let me show you. this one. Okay, these are the value. This is the table. X and Y. X value is given, Y value is given,
As
and you have to find